Okay, so I thought I'd take a brief look at some of the properties of logs, and we'll apply that utilizing, again, delta math, so we can kind of just use it as a bank of some questions and help you kind of understand how to interact with that feature. And so let's just kind of see how this plays out. So one thing that you want to remember is that we have three properties of logs that are major right now that we've dealt with. One of those is that it doesn't matter what base you have, if you have the product of two values within a common base, you could separate those as two separate logs with the same base but added together, and that comes right out of the properties of exponentials, that anything to the same base, when you multiply, you add them together. Similarly, if you were to divide two values within a logarithm, you could turn it into the log of b minus the log of m. And last, you have the log base b of m raised to the n power. Remember that an exponent is just repeated multiplication, so you can bring that out into the front. So I have some problems within delta math that I thought we could look at that would help us kind of utilize those and talk about the properties as they go. So let's share that with this thing right here. So I was going to look at just sort of condensing logs. So in this first example, what you notice is this k is sitting in front. So what I would have, it is the log of c raised to the k power. There we go, c raised to the k power. But then because of the minus that is there, I would be telling it to divide, because that was property number 2, and that y also is an exponent. So that would be d raised to the y power. And that's our next one. So in a similar fashion, let's go a little bit further. So this one, okay, so I have the log of a, and then since there's a minus there, I'm going to divide it by c raised to the second power, because remember in the properties of logs that a coefficient becomes an exponent. Let me go back here a little bit and let's grab a different version of those problems. And maybe we can look at some that are like numerical in nature. So in looking at, they want me to do that problem. So in this case, the log base b, we have 2 times the log base b of 4. Well, that would just be the log base b of 16, because it would be 4 squared. Here, this would be the log base b of 3 to the 4th, which again would be just 3 to the 4th power is 81. Simple little idea. Let's come back here a little bit. Now, when it comes to expanding, that's kind of interesting, because notice this x is to the 4th power, but the y is not. So if I were to expand that out, I would have 4 times the log of x, and then plus the log of y. I really don't, there's nothing more that I could do. When you have a product, it tells you to add, and exponents become coefficients, and so that's all we can do there. In this case, they have different exponents. So the x has a 4th and the y has a 5th. So we could say 4 log of x plus 5 log of y. And we would be done with that. Now let's see if we can get one of these that has maybe a division in there. There we go. I found one. So in this case, I'd have 5 log x. And then I would have a minus, because the division tells me to divide. It's the log of y, but you'll notice that it has an exponent, so we should throw that 4 in front. Now let's see if I can go back and find something even different. So let's go to expanding logs in maybe a little bit of a higher level. So this does get a little bit challenging, because they threw a whole bunch of interesting information at me. And this is really a place where I feel like it would be worthwhile to take a look at. So I have log of a to the 7th, b to the 4th over the square root of c to the 5th. Well, there's a lot of information going there, and it told me that the log of a is 4, the log of b is -9, and the log of c is 6. So I'm not going to do very many of these problems, but I'll do 1 or 2. So let's go ahead and take a look at how that plays out. So according to the rules of logs that we used a moment ago, I could rewrite this as 7 logs of a plus 4 logs of b, and then minus 1/2 the log of c to the 5th power, but that means I could bring that 5 out in front. So reality is this is the 5/2 power. Well, what makes this kind of nice is they have already handed me the answers to all of those. In fact, I happen to know that the log of a was given right there to be the number 4. I know that the log of b was handed right there to be the number -9, and c right here was the number 6. So I've got 28 minus 36, and this would be a minus 15. So it looks like I've got a -8 minus 15, or a total of -23. So let's see if maybe there's another problem like that that we could look at. So here's another one. So we have that the log base a, the log of a is 2, the log of b is -3, and the log of c is 1. And we're asked to do the log of a to the 6th, b to the 6th over c to the 7th. So let's see if we can put that all together just one time. So again, the exponent could come in front. That would be the log of a. Plus I've got 6 logs of b, and because there is a division, we could subtract 7 of those, which is log c. But again, just like the previous problem, they have handed me really nice things. That just this whole thing called log of a was, in fact, the number 2. This whole thing right here, which was log of b, was -3. And the log of c, this entire entity, was 1. So I have 12, take away 18, take away 7, which I believe is a total of -13. And so that's a little bit of utilizing the property of logs to analyze a function. So hopefully that was helpful to you. And please let me know if there's any other way that I can help. All right, thank you so much.